Hey guys, Timmy D with Mid-South Drone Services. And today's video is going to walk you through taking the flight data, the LiDAR point cloud data off of the TopoDrone 100 system, which is a Velodyne VLP16 head. We're going to take it off of that into the PC, and I'm going to walk you through from beginning to end on how to process that data and export out a file that you can bring into Global Mapper, QGIS, or whatever your point cloud editing software of choice is. I'm going to walk you through every step of that process. So we're going to cover strip alignment, point cloud overlap reduction, all of that. I think you'll find it very beneficial. I'm going to have a lot more videos coming out that's going to cover every aspect of LiDAR. There's a lot to learn, and it's easy once you understand it, once you know it. So I'm going to bridge that gap. There's a lot of sales videos out there, a lot of marketing videos. I'm going to bridge the gap. I'm going to teach you all you need to know to use it, to understand it, and kind of demystify it. Again, I hope you like this video. I hope it's helpful. Give it a thumbs up. I'll see you in the next video. This is going to be a tutorial that shows you the workflow from start to finish. When you do your flight, you will insert a thumb drive into the VLP16, and that will automatically copy a zip file for all of your flights onto that zip drive. And then you'll come back, copy those to the PC, and then extract them. And so what you see right here, not the X4S or the RS2, I added that in, but you'll have these files right here. That's what's included in that zip file. And so I'm going to walk you through and show you the workflow. Now I am using Inertial Explorer Xpress, but you can also use the Topo Lidar program for doing that. So I'll do a separate video and show that workflow as well. But this is going to be using the Inertial Explorer Xpress. So let's go ahead and get started. So I'm going to open up Inertial Explorer, and I'm going to do File, New Project, and I'll just use the project wizard. And we're going to create this. And so let's go ahead and we're going to do it in the folder that's being created. And so I'll just give it the same date, 05-14E. Okay. Now it's asking for the data from your rover, which is I'm using the M200, so whatever you're flying on, that's what it's going to come. But this is actually from the VLP16 unit that is mounted underneath my M200. That's where this is coming from. So here's the UBX file, which is the GNSS log file. And then I also have the IMU data, which is attached to that. It's all built into one unit. So I'm going to browse, and that'll be the IMR file. I'll click on that and do next. And what it's going to do is go through and convert that UBX to the, I think it's GMB format, which is what Inertial Explorer is using. So I'm going to go ahead and click next here. Now, I do not want to add precise files, so I'm not going to do that. Click do not add and then do next. And now we're ready to add our base station information. So I have an MLID RS2 unit, which I use for my base unit. So I'm going to hit next, and now it's going to ask me to import that file. So I'm going to do browse, and now I already have that in here. Here's the UBX file here. So I open, and I've already post-processed that base file to get the precise coordinates for that. So I'm going to hit next, and it also has to convert this to the GPB format. That's what it uses within Inertial Explorer. It'll take just a second. It'll convert that, and then we're going to open up my text file where I have my PPK coordinates recorded for that, and then we'll update Inertial Explorer with that information. So I'm going to go ahead and hit, oh, actually it's already moved on. So now okay, so here I have, this is my PPK coordinates, and so what I'm going to do is copy that into these fields right here. There's that one, and then this one. And you can see ellipsoid height is 83.562. So I'm going to do that, and then 3.562. Okay, and we're going to hit next. Oops, forgot my datum. And I'm going to go ahead and use WGS84, and you can leave the epoch year blank, and we'll hit next. Okay, do next, and then finish. All right, so what this is the trajectory. And so you see the trajectory, and then the blue dots, I actually have the X4S camera mounted, and so everywhere that a photo was taken, that is the point, or the event is what it's considered in the trajectory file. The next thing we need to do is let's go back up to the root folder. This IMR file, we're going to need to open this up, and we're going to see our GPS times. So I'm going to double click on this, and you can just press any key to continue. And you either have to scroll down or enlarge the window just a hair. I don't know why it does that. But, and then you see right here where it says B for bottom of file. So I'm going to hit B. And that takes me to the end of the file. And now I want to save this file. And you're going to see why in just one quick second. So I'm going to save the file. Now you see right here it says F for full. Okay, so I'm going to do F. Now the output name, we're going to do it start in times.txt. And then what that'll do is that'll actually save the file in the folder. So we're going to be back over here. I'm going to hit enter. Okay, output complete. Now we can quit. So I'm going to hit Q, any key to continue, and it quits that. Okay, now when I open up the start and end times file, let's move it up. What this is the logging. This is the log time. Okay, the log time started. This is the very beginning. If I come all the way to the end, this is the end. And in a minute, we're going to need the start and stop time. So what I'm going to do is I'm going to delete this second row. So I'm going to go from there, come all the way down, and I'm just going to leave the first and last row of time right there. Okay, so we'll need that in just a second. And let's go ahead and move this out of the way. Okay, so the next thing we're going to do is we're going to do our process, and we're going to select tightly coupled. I'm going to click on that. Now, the first thing, and this tutorial is assuming that you have already gone through and set up the initial settings, profiles, all of that. And I'll have a separate tutorial on how to set all of that information up. So you'll do that one time, and then moving forward, you'll never have to mess with it again. So first thing I'm going to do is come down and select my TopoDrone profile. We're going to stay with the same datum. I'm going to click on Advanced GNSS, and here's where we're going to use the times. We're not going to do the entire file. I'm going to specify the start and end time. Bear with me. Okay. Now, this is the start time. And then let's copy our end time. Oops. All right, there's the end time. Okay. Now I'll click on OK. And then let's do Advanced IMU. And we're going to use the GNS start end time, which we just specified. So I'm going to click on OK, so that now both of these are using the exact same start and end time. And we do not, I'm going to uncheck where it says Read Rotations. And under Vehicle Profile, I'll click, and I'm going to choose the profile that has already been set up for my M200 with the X4S on it. So I'm going to click on OK. This data right here has already been populated before, so there's nothing to change. And I'm just going to click on Process. And it'll take just a second. It's going to pop up. This window will pop up, and just go ahead and click on Continue. And so what you're seeing now is it's doing a forward and reverse processing of the trajectory file. And so when you see these numbers right over here, 1 is the best, that's a fix, and it goes from 1 to 5. And so that's telling you what the status along the trajectory. And so Obviously, we want one always, but it won't always be that way. So anyway, it's going to run this forward and backward and do a smoothing process to have a post-processed trajectory file that we'll see here in a minute, and that should be green. All right, so it is now complete, and what you're seeing, I have Inertial Explorer Xpress, which is the cheaper version, and the blue line is because there is a radius. It's 3 miles, I believe that's right. 3 miles? 4? I had to go back and look. I think it's 3. But from the base station, your project data, which is right here, this flight, it can only be within, because my base station is right here. See this little triangle, my RS2 base. But when you're flying large areas, when you have the Express version, your flight can only be a maximum of 3 miles from the base, which is not an issue. You just have to pick up, move your base. If you have a long, say you had a 10-mile long pipeline, I would have to move my base during that mission, or set up multiple bases and just process those flights in batches. Anyway, I hope that makes sense. And so we are done. We're now ready to export. So I'm going to go to Output. I'm going to go to Export Wizard. And the TopoDrone profile should already be selected. Once we've set it up, it'll always be selected by default. I'm going to hit Next. And we're just going to use the WGS84 datum. So hit Next. And here again, everything is already here. I don't have to change anything. So I'm hit Next. And again, everything, what I could have done is select Finish. I didn't have to go step by step because it's all set up. So I'm going to hit Finish. And this is going to export. This is just a preview of the file. I'm going to close it. And we're done. So what I'll do is I'll go ahead and click File and Save Project just to save it, and then we're going to close this out. The next thing we're ready to do is open up the Topo Lidar software, and this is what we're going to use to actually generate and create the point cloud file that we will then bring into Lidar 360 for final processing. Now, I mentioned earlier that you can actually use this program for processing your GNSS and IMU data, which is right here. I'll do another video with that workflow, and so that if that's the route you're going, then you can see that from start to finish. But now we're ready to actually do the point cloud generation, and so I'm going to come up here and click Browse, and we're going to the E folder. This PCAP file is what we're going to load up and hit Open. It'll automatically default to the same folder for your output, so leave that. And then we're going to get the track file, which is the position file, POS or trajectory file. So I'm going to browse, and it also will automatically be in that same folder. Okay. Now we can go ahead and transform our coordinates to whatever you want to use. So if you're using a specific coordinate system, then go ahead and pick that. So I'm going to use the CONUS Zone 7 for my geoid, and we'll stay with, for this, WGS84, and then go down to UTM. Go down here, and I'm in Zone 16 North. Okay. Now, calibration, we already have a preset set up that I'll use each time, so I just click on preset, and I come, and I'm going to load this one. So I click it and hit select, and you see that it made these adjustments right here, and we are ready to start. And so I'm going to click on start, and what you're going to see over here in the right, or excuse me, in the left side, is the real-time point cloud generation. It starts generating these points, and you will begin to see it kind of show up on the screen, and kind of neat. It's not anything that's necessary, but you are just seeing in real time that it is generating the point cloud. And this doesn't take very long, and it will be finished, and then we'll be ready to move on to the next step. All right, so when it's done, I'm going to close this. Now I'll tell you this, there is a delay, there's a longer time because I'm doing a screen recording. When I'm not recording, this was right at 20 seconds to do it. So basically 3 times as long because I'm doing a screen recording. But without that, 20 seconds and it was done. But we're through. We can go ahead and close the Topo Lidar software. And the next thing we'll do is move into Lidar 360. Okay, so we're going to open up Lidar 360. All right, so you'll have your start page. I can close that. When you come into Lidar 360, the first thing you want to do is right mouse click on point clouds. And one thing I'll mention, this is version 5. There was actually a pretty significant change in the layout from version 4 to version 5. So it does all of the same things, but it's just laid out different. So I won't be able to help you with version 4, but if you're running version 5, this will be step by step and work out nicely. All right, and if you need this, chances are you are new to the LiDAR processing and you'll be on version 5 anyway. So, all right, right mouse click on point cloud and choose import data. And we're in the correct folder, which is this E right here. The first thing you have to do is change it from LiData to the LAS or LAZ format, Z being compressed. And so we're going to select, this is the file that was output generated by the Topo Lidar software. So I'm going to open that up. And when this screen pops up, you just click apply. There's nothing to be changed. And then you'll see down at the bottom that it's giving you the process of importing. And so here we are. We're looking at the intensity format, but you can see this is the roadway here. And matter of fact, let's switch over to elevation and turn that on. All right, so this is the house right here. This is the roadway up here. And and again, the flight lines were running north and south right here. Okay, so I just wanted to show you that. And now let's go back to intensity. Okay. The first thing we need to do is we're going to click on pre-processing, and I'm going to click on bore site, and I need to open the trajectory file. So I'll open that, and it says, hey, select the workspace. Well, that's just the folder where everything resides, and we're already in the right folder, but I'm going to set it. And now we need to open the trajectory, and you'll see there are 2 here. This short one, well, the one with the projection UTM zone 16 in, that's the one where we actually set the projection. That's the one you want to open, and whatever you set using the Topo Lidar software, it'll have that name. That's the one you want to select. So I'm going to open it, and this box will pop up. Now, the very first time you do this box will be short. Just grab the end of it, move it out, and you'll never have to do it again. It'll always be the right size. So the first thing we have to do is go across this heading row and set the proper column headings. And of course, what's in the pink is telling you what it should be. So this one's going to be grid X, grid Y. This will be height, roll here. And every time I click, I just roll my mouse all the way up to the top. I can find it. Roll, pitch, heading, and then GPS time. So we have those selected. They are correct. Then we come down to skip lines, and I'm going to say I want to skip line 1, which was nothing more than the headings. I'm going to click on apply. And when that happens, we'll now see the trajectory path show up. And so here that is. Now what we have to do is we have to select what we're wanting to keep for our processing. And of course, what you're seeing here is that the drone took off here, went out, we did the calibration flight. So one of these circles is in, I think this one was done in clockwise, then this one came and did counterclockwise, then it flew over here to start the mission, and then in UGCS I have it set to where it's doing adaptive bank, so instead of making sharp 90-degree turns, it's making rounded turns, and I also set it to have a 10-meter overshoot, so they go past the line 10 meters, make a turn, and come back to stay smooth. That's better for LiDAR. So the first thing we have to do is we have to draw a polygon. So I'm going to click Draw Polygon, and I'm going to come right here, single click. I come across, single click, and I can roll my wheel mouse in and out to zoom wherever I want to be. I'm going to come about here, single click, and then to close the polygon and finish it, double click. Okay. Now, once you've finished it, you come and click on Select by Polygon, and you'll see that it now has selected these flight lines that were just within the polygon that I drew. Okay. So now the next thing we have to do is we have to split the trajectory. And what that'll do is that's going to split these trajectories so they're all individual. So I'm going to click Split. Okay. That got rid of everything that was outside of that box. But what you can see is that we still have some that were inside the polygon that we don't want to keep, right? So it's very easy to get rid of those. I'm going to come down here on the bottom left corner, drag this up a little, and these that we don't want to keep, we're simply going to right mouse click and choose Delete. Yellow one, Delete, and the teal colored, I'm going to right mouse click and choose Delete. Those are gone, and I'm only left with 3 flight lines that we're going to use for our processing. So now the next step is we're going to take this cloud, this point cloud, we're going to split it up, and we want to split it up by our trajectory paths. So I'm going to come up here and say Cut Point Cloud based on trajectories, and so I click on it. I'm going to hit OK. There's only one point cloud right now. I'm going to hit OK, and you always choose Add Data to Current Project, always. Now what I'm going to do is I'm going to uncheck this one. And then the next thing, we're going to match point cloud and trajectory. So I'm going to just simply come up here and click Match. What you're seeing is that in the blue, this blue flight line, here's all the data that was collected during that flight path. And there's overlap. The white one, you can see the white goes from right here over to here. So that in this path, there's everything that was collected. And for this pink colored one, all the way to the far right as far as over here. So there is a lot of overlap between these 3 flight lines. And we're going to get rid of a lot of that. We're going to use that for alignment, and then we're going to actually get rid of all the overlapping points a little later in the process. So it doesn't matter whether you either match the point cloud and trajectory first or delete this first, but this particular LiDAR set right here, point cloud, we no longer need this one. So if I turn it back on, that's the one that is was before we split it. So I'm going to just right mouse click on it and choose Delete, Remove right here, and it's gone. We didn't need it. So we're going to do calibration. I'm going to click on Calibrate, and then I'm going to click, let's get here. Now you can I can drag this around, move it around, but I'm going to click on Calculate. And when I click on Calculate, it is going to go in and automatically figure out what it thinks is the best calibration for the flight that was done. And so what I'm going to do right now is I'm going to click this very bottom tool. This is what you call your profile tool. So I'm going to click on that. When you are looking at a profile, one of the hardest things, I guess, for somebody brand new to LiDAR is learning how to look at it. You have to learn to look at it with LiDAR glasses. Learn what you're seeing and what it means. This buffer right here, if I draw, and I'm just going to show you an example. These are my flight lines, and so what I'm first going to do is I'm going to draw a profile that's going along the path of the flight lines. But what I really want to do is I want to fly it along where a roof line is at. When you are doing your calibration, you really want to have roofs and defined structures, and it will help you to get your flight lines in alignment. So I'm going to click here, and I'm going to run this. So the line over here on the left that's sticking straight out, that is just giving you a 90 degree to give you a reference to which direction you're going. So I'm flying with the flight line, which actually is in alignment with the roof of the house. So I'm going to click once and I click again. Now, as I drag this mouse to the right, that is the depth of what it's seeing. And as a matter of fact, the line that is pointing to the left, that's the direction that we're looking. And when I've dragged my mouse in and out, what I'm defining is how deep of points am I looking at. If I did this right here, you see down below it says 24.82 meters. You're looking at 24 meters worth of points, which would be absolutely useless. We don't want that. We're trying to take a very thin slice, and I mean really thin, to look at, say, a roof line, a point line. And so I can either set it manually, or I can just come down here and click a box. And what's really good is to use 1/10 of a meter, 10 centimeters. Okay? And now I'm going to hit, let's see, I'm going to go do it again. Go up. Boom. Okay? Now I'm at a 10 centimeter depth, which is very, very shallow. And what it is, I'm looking from this direction over here, looking this way across the roof. And there's actually a point. So if you can see my mouse where it's running right here, that is this area down here. This is the top of a roof line. Now we see the pitch of this roof, where this line is at right there. There's another roof line running left to right, which in this case is east to west. And you're seeing the points. Well, you can see right here we have a point in pink, a point in white, and a point in blue. That's because they are not aligned up. When your drone is flying back and forth, it's flying at different angles. And so that is what you are accounting for during this process. That's what the calibration is. Okay? So this is the values that were generated automatically by the software. When I said calculate and it did it automatically, this is what it came up with. And so I'm going to click on apply and look down at the bottom to see what happens. Okay, that's pretty good, but there's still some misalignments. You can see the white right here, and then the blue and the pink over here to the right. So it's not in perfect alignment. You can take time to play with these values and get them to where they are as good as they can possibly get. And when you draw your profile line with the flight line, what you're looking to adjust is your heading and your pitch. So those two you should adjust by drawing the profile with the flight line. Then when you get ready to adjust the roll, we're going to draw a profile across the flight line. And then that's how you're going to fine tune it. But what I'm going to do is, once you get your values and you get them set to where, hey, this is spot on, when you mount the LiDAR unit on your UAS, your drone, it should be in the same identical position over and over and over. It should never change. And so once you get settings that are good, they should stay the same flight after flight. So you won't have to do this but one time. Go out, fly a mission, sit down and work to get all of your calibration set as good as it can be. And then moving forward, all you're going to do is you're going to come in and you're going to say, hey, I want to open up a flight line. And so I have right here where I did a couple iterations, and this version 3 is what I think to be the best. So I'm going to open that. Now when I click apply, watch the lines down here. See how they're in alignment. They're just mixed together like peanut butter and jelly. I mean, well, maybe coffee with creamer is a better illustration on that. But so that brought this into really nice alignment. So again, you remember I drew the path north to south, which is with the flight lines. Now what I want to do is I want to come across, and I want to do it where the roof line is. And again, by changing this to that color, I can actually see there's my there's the dormers. Well, I know that the roof line is running right across there. So that's a good place. You want to run across a roof line. So now I'm going to run perpendicular to the flight lines. So I'm going to click here. I'm going to come across.
And if I drag all the way over, then you'll just see more. I'm really only interested in seeing the roof. That's where I'm going to get my calibration basis from. So I'm going to click again, and now you see we are looking front to back. Okay, and let's go back to intensity. Well, that's not what I wanted. Okay, so what I want to point out is that I changed, what I did is I came over here and I changed to a different display, okay? And when I did, you cannot, there's not a display over here to match your flight lines by your trajectory path. You cannot do that. So what you have to do is come back up here. If you did that by accident, you can come back up here and say match point cloud again. Now we go back to every cloud is matched to the trajectory. Now, what I want to show you is that see how everything is uneven. Let's move that down. Zoom in. See how our paths are crisscrossed here? Now, I'm going to come back up to calibration, and I'm going to apply the calibration, and they go back into alignment. And so again, we're looking across the roof line, and is this the, let me make double sure that this is the open 03 apply. Yes, it is. Okay, so we have now, we know that this is the correct calibration, but all that did was apply calibration to what we have previewed on the screen. It has not been made permanent yet. So in order to do that, you come back up to the top and you click on selected point cloud files, and when I click apply this time, it is now applying it not to what's just loaded in like temporary on the screen, but it in fact is going to apply it to these files over here. So I'm going to click apply, and it'll take just a second. It'll run through, and it is now done. So one of the things I mentioned, and now that we're done with the calibration, we can go ahead and close this profile preview. So I'm going to come up here and click in this top right corner right there. You know, I'd already mentioned before that we have a lot of overlap. So the blue this side, white in the middle, pink on the right. What we're going to do is tell LiDAR 360 to get rid of all the excess overlap that is not needed and only keep just a little bit. So you do that by simply coming up and clicking on cut overlap. It's saying, well, what do you want? I mean, you could, if you had a reason, to only select, say, two different flight paths to cut. We're going to cut overlap with everything we have. So I'm just going to leave everything selected, choose OK. All right, so one of the things I mentioned earlier is that we do have a lot of overlap. And you can see the blue on the left, white in the center, and the pink on the right. So the first thing, we need to go through the process of getting rid of all that overlap. So I'm just going to click on cut overlap. It'll come up, it'll have all three flight lines selected. Just click on OK. And now we're going to change, and we're going to view by classification. Okay, and so I'm going to come over here to where it says C. I'm going to click on that. You now will be able to see all of your overlapping points. So what it did is it went in and classified all the points that are overlapping in yellow. So I'm going to click on OK. And now you can see all of these points in yellow are overlapping points that are not necessary. There's yellow ones and white ones. And so now that we have classified the points as being overlapped, we're going to click on cut overlap one more time. And this time, instead of classify right here, we're going to click on delete because we've already classified them. So all of the points that were previously classified as overlap, they're now going to get deleted. And so when I click on OK, it will get rid of those. And now it will ask me if I want to add this data with the deleted overlap to the current project. Always choose yes. Okay. And I'm going to move this out just a little bit. And so if I delete, I can see overlap because these were still turned on. Again, we don't, I will keep these. We don't really need them because now we have new files. But in this case, it might be good to hang on to these in case you need to go back and rework a certain step. Now, this is for the primary purpose of creating either DTMs or DSMs. If you're doing 3D modeling or doing something, you have another purpose other than contours and doing DTM related stuff, then you may want to keep some of the extra points. But for the purpose of what we're doing on the DTMs, we definitely want to get it thinned out because it's data that we do not need. We've thinned out, got rid of our overlap, and we're now ready to move on. So in the next step, what we're going to do is actually merge. We have, look, if I uncheck, you see how we have in this one file, now it ended up actually having a few little extra points that are over here, which technically are still overlap points, but maybe the angle that these two flights were at, it didn't pick those points up. But what we want to do is we're going to come in and we're going to merge these together into one file. And so I'm going to go to click on Tools, and I come down to the very end and click on Other Point Tools, and I'm going to click on Merge. And that will now take all three of these and merge them into one. And they're already selected here, what we need. I'm just going to click on OK. And here again, when it's done, it's going to say, well, do you want to add the new data to the current project? And yes. And so now up here, we have this new file, so I can actually unselect those. We're through working with them. And all right, so one thing I want to point out is before we do our final export, the last thing we want to do is do what we call remove outliers. And when you look down here, you can see these 3 points right here, and who knows, there could be I don't see any more. But these are just kind of rogue points that are just out in the middle of nowhere. And we can get rid of those running a process called remove outliers. Even some of these would be considered outliers. They're just kind of out here all by themselves. You know, you can actually clean this up and clip it by a box, but for the sake of this tutorial, this will be the last and final step. So I have merged data. That's the only right here. That's the only cloud selected. I'm going to come up. You've got tools selected here, and I come down to other point tools, and the very first option says remove outliers. I'm going to click on that, and I go up to, or actually it'll be at the bottom. That's the only file selected. I'm going to click on OK. And these down here, it should get rid of these points. And then it'll create yet one more cloud file. Yes. And that is the final one. Oh, forget, we got to turn that one off. And now you can see that those outliers are gone. I would say this file is ready to export out, whether you use Global Mapper, QGIS, Cloud Compare, whatever your point cloud editor of choice is, you now can export this file out. What we'll do is, this is the layer that we'd want to export. That's the final layer. Right mouse click, choose export, and you can do several different formats. So you've got these LAS and different versions that you can do, an ASCII format, PLY, and E57. So you just pick what format you want to do, export it, and then you are now ready to bring it into your other editor. I will be doing some more videos on classification of the point clouds, and hopefully a lot of other helpful information to help somebody new to LiDAR just understand what you're working with, how to set it up. So hit that subscribe button. I hope this was helpful. If it was, please give me a thumbs up. It helps the channel, and thank you for watching.